In the next video, we'll discuss the concept of density. Density is a substance mass divided by its volume. Objects that sink in water, for example, are more dense than water, and those that float are less dense than water. We see here that water is 1 gram per milliliter. Ice floats in water, it's 0.92 grams per milliliter. Cork is 0.26 grams per milliliter, or at least this cork is. Aluminum is 2.0 grams per milliliter. Lead is 11.3 grams per milliliter. Density is an intrinsic property which doesn't depend on how much substance you have because you're dividing the mass by the volume, which makes it independent of the amount of substance. And for substances like aluminum and lead, their density doesn't change from one sample to the next. For substances that can vary, like body fat and cork, the density can change from one sample to the next. But here are some densities of common substances. We see that aluminum is 2.70 grams per milliliter. Iron is 7.86. Copper is 8.92. Cork is 0.26. Muscle is 1.06. Ethanol, that's the kind of alcohol people drink, is 0.79. Urine is around 1. Well, it's aqueous, it's water-based, so that makes sense. Milk is a little higher than 1. Helium 0.179. So helium is very low. We see that hydrogen is even less dense than helium at 0.090. And neon is 0.902. So density is mass over volume and is often expressed as grams per milliliter, but for gases, density is expressed as grams per liter. Again, density is calculated as the mass of a substance over the volume of a substance. The density of a liquid or a solid is given in units of grams per cubic centimeter or grams per milliliter. Remember, 1 cubic centimeter is 1 milliliter. The density of a gas is usually expressed as grams per liter. In order to calculate the density of a solid, you can measure its volume with a ruler, or you can measure its volume by displacement. So you can put a solid into something like a graduated cylinder and measure its volume by the displacement of the liquid in the cylinder, in this case water. So you can see here that we've measured the mass of this metal rod on a scale. So we put the mass in the numerator and we divide by the volume, which is calculated here by displacement. We take a graduated cylinder and measure the volume, then we put the rod into the graduated cylinder and it displaces the liquid. The amount of displacement is the volume of the object. So in this case, our volume was 45.0 for the final volume minus 35.5 for the initial volume, giving us a volume of 9.5 milliliters. So we can measure the density of the zinc rod, or we can calculate it, because we calculated the volume from displacement. The final volume was 45.0 milliliters minus the initial volume of 35.5, which gives us a displacement volume of 9.5 milliliters. The zinc rod displaced 9.5 milliliters of water, and therefore the zinc rod has a volume of 9.5 cubic centimeters. It displaces the amount of water equal to its volume. We weighed it on the scale and its mass was 68.60 grams. So in order to calculate the density, we divide the mass by the volume, 68.60 grams, divided by 9.5 cubic centimeters is equal to 7.2 grams per cubic centimeter. What is the density of a 48.0 gram sample of a metal if the level of water in a graduated cylinder is displaced from 25.0 milliliters to 33 milliliters after the metal is added? So we see that the volume can be measured by displacement as 33.0 minus 25.0, giving us a volume of 8.0 milliliters for the metal. The metal weighs 48.0 grams, and therefore, in order to calculate the density, we can divide the mass by the volume. That's 48.0 divided by 8.0, and we get 6.0 grams per milliliter. Grams per milliliter. Those are units of density. It's mass over volume. We can either express it as milliliters or cubic centimeters. They're equal. Let's say we know the volume and the density of a sample. Then we can calculate the mass in grams by using density as a conversion factor. For example, John took 2 teaspoons of cough syrup. If the syrup had a density of 1.2 grams per milliliter, and there's 5 milliliters in 1 teaspoon, what was the mass in grams of the cough syrup? We see here that we're given 2.0 teaspoons of syrup. We need the mass of the syrup, and in order to calculate it, we can use density as a conversion factor. Before we get started, we'll need to convert teaspoons to milliliters, and then we can use density to convert milliliters to grams because we know the density of the cough syrup. We're told that 1 teaspoon is equal to 5 milliliters, 5.0 milliliters, and so we can use 5.0 milliliters per teaspoon as a conversion factor. We're also told that the density of the cough syrup is 1.20 grams per milliliter, so we can use that as a conversion factor. Starting with 2 teaspoons of the cough syrup, we then multiply by the first conversion factor, which is 1 teaspoon is 5 milliliters. We're limited to 2 significant figures from this problem, 5.0 milliliters, because we're converting from the empirical system to the metric system. Next, we multiply times the next conversion factor, which is 1.20 grams per milliliter. That's the density of the cough syrup. This limits us to 3 significant figures because this density is a measured value. We had to measure the mass and the volume of the cough syrup to get that density. So we're going to multiply 2 times 5 times 1.20 and then hit equals on our calculator. We could divide by 1 and then hit equal and divide by 1 again, but the 1 doesn't change the value, and therefore our answer is 12 grams of cough syrup. Now, we're limited to 2 significant figures because we started with 2 significant figures in our initial value and the 2 significant figures from the 5.0 milliliters per teaspoon. Let's work another example. An unknown liquid has a density of 1.32 grams per milliliter. What is the volume of a 14.7 gram sample of the liquid? So we're starting with 14.7 grams of the liquid. And we know that that liquid has a density of 1.32 grams per milliliter. So in other words, 1.32 grams of the liquid is equal to 1 milliliter for this particular liquid. It's 1.32 grams per milliliter. So we can write that as a conversion factor of 1.32 grams per 1 milliliter. Now, which value do we need to put on the top and which goes on the bottom? The grams has to go on the bottom in order for grams to cancel. So we have 1.32 grams per 1 milliliter for this particular liquid. And now grams will cancel and we're left with milliliters for our units. So if we multiply 14 times 1 and then hit equal and divide by 1.32, we get 11.1 milliliters because grams cancels and we're left with milliliters. Next, we'll discuss a concept called specific gravity. Specific gravity is the relationship between the density of a substance and the density of water. It's calculated by dividing the density of the sample by the density of water, which is 1 gram per milliliter at 4 degrees C. So if you divide a number by 1, you get the same number. And so generally, this is going to be equal to or put it pretty close to the density of the sample, but it can vary a little bit by temperature, and if that's important, we sometimes use the term specific gravity. So remember, specific gravity is equal to the density of the sample divided by the density of water, which is usually the density of the sample divided by 1. Because you're dividing density by density, you're dividing grams per milliliter by grams per milliliter, and therefore the units cancel, and this is a unitless quantity. We've covered a lot of material in this chapter. We covered measurements, measured numbers, significant figures, how to round our answers, and when to add zeros. We covered prefixes, metric units, equalities, conversion factors, and problem solving. We covered length, mass, volume, temperature, time, and how mass and volume relate to density and specific gravity. Join me for the next chapter.